second half of this section, which I don't know why it's in the same section. I do a little bit, but I really wish they would do this separately, is binomial expansion in Pascal's triangle. Pascal's triangle is very easy to generate. And I'll show you how to generate it really quick if you've forgotten. We did it earlier in the course. You start with a triangle of ones. Down the sides of the triangle, you're just going to keep writing one on both sides. This is really considered row 0. This is considered row 1. The next one will be considered row 2, and so forth. Row 2, we have 1s on the sides and a 2 in the middle. Row 3, we have 1s on the sides and we have 3 in the middle. Notice how each row has one more term than the previous row. 1, 4, 6, 4, 1. Pascal's triangle, you could generate 10 rows in about 30 seconds. 1, 5, 10, 10, 5, 1. If you're not remembering the pattern and how this generates, it's really easy. Like I said, the 1s come down, and then it's 1 and 4 makes 5. 4 and 6 is 10. 6 and 4 is 10. 4 and 1 is 5. And we have a 1 at the end. Every row, row 2 has 3 terms. Row 3 has 4 terms. Row 4, 1, 2, 3, 4, 5 terms. You always have one more term than the row you're looking at. And again, 1, 6, 15, 20, 15, 6, 1. And the rows are always symmetric. So on the ends here in row 6, we have 1s on the ends. Second and second to last term are 6s. Third and third to last term are 15s. And 20s in the middle. Row 7, 1, 7, 21, 35, 35, 21, 7, 1. And like I said, you can really generate Pascal's triangle rather quickly. Well, Pascal's triangle clearly would go forever. You could do row bazillion and 12. Okay? But that's not, the reason why we're doing this isn't, ooh, look, cool triangle. There's got to be something to it. And what we're going to do is we're going to be looking at binomial expansion. That's one of the uses for Pascal's triangle. Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, etc., can be found, each of these terms can be found by taking the row number in the row, the position in the row, starting with the 0 position. So when we look at this 3 right here, you're in row 3, it's combinations of 3 taken one at a time. You start with combinations 3, 0, combinations 3, 1, combinations 3, 2, combinations 3, 3. Your outsides are always going to be 1s. We learned that yesterday. So if you know Pascal's triangle, you know combinations 3 taken one at a time is 3. But you also know that combinations 5 taken 2 at a time is 10. And 5 taken 3 at a time is 10. And 5 taken 4 at a time is 5. So these combinations give you these numbers in Pascal's triangle. So if I go back to Pascal's triangle here, and we know this is row 7, this is going to be 7 taken 0 at a time, 7 taken 1, 7 taken 2, 7 taken 3, 7 taken 4, 7 taken 5, 7 taken 6, and finally 7 taken 7 at a time. I'm not trying to suggest that you use Pascal's triangle to identify what the value of a combination is. How should you be doing that? Okay. You should be using your calculator. To do binomial expansion, we're going to recognize that these values, the 1, 5, 10, 10, 5, 1, are the coefficients when you take a binomial and raise it, in that case, to the 5th power. Row 4 would be the 4th power, row 3 would be the 3rd power, and so forth. So that's what we're going to be using Pascal's triangle for. We are not going to use it to answer a question like this. The 6 members of the Model UN Club, you must choose 2 representatives to attend the convention. Use Pascal's triangle to find the number of combinations of 2 members that can be representatives. What's my combination? 6 taken 2 at a time. Do I really need Pascal's triangle for this? No, just do it on your calculator. Okay? I really want to see the 6 factorial, 6 minus 2 factorial, and 2 factorial, and then plug in your calculator.
Why would you need to use Pascal's triangle?
Well, remember, we didn't always have calculators like this. This technology, which you're so used to, even when I was in high school, we had calculators, we had scientific calculators, but it would not do a combination. So we could only get to here, and then we had to continue on from there. And if you had Pascal's triangle all done, once you have it done, you don't, I mean, obviously it's going to be faster than using the calculator, right? All you got to do is look at it. So, you know, if you have rows, if you're doing 6C2, here's 0, 1, and 2, that's 15 ways. It's pretty fast. So there's the benefit, but I don't know that I really want to do combinations that way.
For going back for the 6 and 2 combination.
On the problem I did, or on the triangle?
For the problem.
Down here.
Yeah. I know you want us to write it like that, but even if we can just put it in the calculator as 6 and then the NCR button into.
But I have to, this is all I'm asking is show me this, and then do the NCR button. I don't want, when I say do with the calculator, I didn't mean to plug this in.
Yeah,
okay. I mean bang away. Okay, so I have no problem with that. I just want to know that you know what we're doing with the NCR button. Okay, good clarification. But this is what I'm really concerned with. Can you use Pascal's triangle to expand a binomial? And we talked about it briefly earlier in the course. The power n is the row on Pascal's triangle. Did I make a mistake? Is something on me or what? Did I miss something? You're not going to tell me.
This is Christian Newton.
All right. Christian. Oh, Christian's here tonight? Good to have you with us. All right. So again, do you want to use the combinations? It just seems pointless to me. I usually just roll out Pascal's triangle, and then if I'm raising to the 4th power, I just copy the coefficients 1, 4, 6, 4, 1, which is what they did for you right here in red. 1, 4, 6, 4, 1. And then you can look at this and say, oh my gosh, this is so confusing. This is Pascal triangle row, the C's, the combinations. And then this is the first term to the power of n, and the second term to the power of 0. First term to the power of 1 less than n, and the second term to the power of 1. And I'm going to take you through this so that you understand what's involved here. And when you have a number in here or a power on something in the binomial, it's going to make things really complicated. I would encourage you to turn your paper sideways, you know, so it's the long way at the top. And I would tell you to write extremely neatly, and you're not going to screw up. Those of you who don't, and you try to do the Candyland approach, or you're not very neat, you're not going to get it right.
Did you get the row 4 from the exponent?
The power tells you which row to use, exactly. Great, right? So let's take a look. This is a plus b to the 4th. So what we're going to do is we're going to start with the 4th row of Pascal's triangle. 1, 4, 6, 4, 1. Now this first binomial that we have is plus in the binomial. That means everybody's plus. There's no way you're going to get a minus. So it's plus 4, plus 6, plus 4, plus 1. Does everyone know where I'm getting those numbers? The 1, 4, 6, 4, 1? Everyone good on that? That's the fourth row of Pascal's triangle, and the power tells me to use row 4. Remember, when you take a binomial and raise it to the fourth power, how many terms will you get? Better known as 5. One more than the power, so that's how we're going to get 5 terms. Same as the fourth row. The next thing I do is I'm going to take an A, the first term in the binomial, and every one of these is going to get an A. And then I take my power 4, and I put that 4 on the first A. And then I just count down. 4, 3, 2, 1, 0. Right? Okay. Then I take the second term, B, and it's going to go here, 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 here. And we go backwards now with 4, 3, 2, 1, and 0. Why do I go backwards? That's just the way the powers work on the second term. On the first term, it's b to the 0. On the last term, it's b to the 4th. The last term, the second term in the binomial gets the b to the 4th. Gets the 4th power. The first term in the binomial gets the 4th power in the first position. If you look at the powers on the A and the B, what do you notice about the powers in each of my terms? Anyone see a pattern to that? They add up to 4, which is the degree of the binomial. 4 plus 0, 3 and 1, 2 and 2, 1 and 3, 0 and 4. Now that won't always be true at the end of a problem, but it will be true on the first line. And I'll show you why it won't be true at the end of the problem here in a moment. So in this particular problem, there's very little to simplify. All right, this one is going to become simply a to the 4th. This is 4a cubed b, 6a squared b squared, 4ab cubed, and b to the 4th. So there's just not that much that we need to simplify in this problem. The reason for that is, 1, there's no coefficients in the binomial. There's no numbers multiplying a or b. And 2, there's no powers on the a or b in the binomial. So that makes life very easy for us. All the more reason for you to see how meticulous I was in generating this answer. Because if you can set it up correctly here, it'll make it much easier when it's going to be complicated, like the next case. Is everyone following what we did, or what I did here? Everybody good? Then let's make it a little bit more complicated. We still went with a plus, so that makes everybody plus. But we have a power of 2 on the x. So my first term is not x, it's x squared. My second term is y. My power on the binomial is 5, so I'm using the 5th row of Pascal's triangle. The 5th row of Pascal's triangle is going to have coefficients of 1, 5, what's next? 10, 10, 5, and 1. Everybody's a plus. And the reason why they're all pluses is because the binomial is a plus. The first thing I want to make sure is if this is a power of 5, I should get 6 terms. 1, 2, 3, 4, 5, 6 terms. In the first position, x squared goes in parentheses for every one of these. power on the first x squared is going to be 5. So we're going to go 5, 4, 3, 2, 1, 0, plus. In the second position, we have the y. Notice I didn't put the y in parentheses because it's just a y. And then we start over here on the right, and the power on the y is 5, 4, 3, 2, 1, 0. But this time you have to clean up the mess. Because of the parentheses raised to powers, you're going to have to do some simplifying. X squared to the 5th becomes x to the 10th. Y to the 0 is 1, so it's just going to be x to the 10th. Plus 5x to the 8, and then y, plus 10x to the 6th, y squared, plus 10x to the 4th, y cubed, plus 5x squared, y to the 4th, plus y to the 5th. Now the powers don't add up to the same thing, I'm aware of that. But if you look at the powers in the first row, we have a 5 and a 0, a 4 and a 1, a 3 and a 2, a 2 and a 3, a 1 and a 4, and a 0 and a 5. And they do all add up to 5 there. But it doesn't work at the end of this one because of the x squared. So the first one was easiest because it was just an x and a y, and you're raising to a power, and it was positive. This one's a little bit more complicated because you have to simplify the powers. The next one's going to be one step more complicated. Right?
Do we stop there?
Here, do you see anything else I missed? If there's something I didn't do that we should, tell me. In terms of simplifying. Nothing else we could do. If you could combine them, which you're not going to be able to, you would want to combine them. There will be some other steps that we have to do on the next one. Okay? But this one, all you can do. Remember, we got rid of parentheses, and there's no like terms to combine. That's what we mean by simplifying. Everybody good? So this one, we now have a minus, and we have a coefficient. So I'm going to tell you how to deal with the minus first, and then we'll deal with what to do with the coefficient. The coefficient works like the x squared. So again, we're looking at the 5th row of Pascal's triangle. So it's going to be 1, 5, 10, 10, 5, 1. Now, this is where I know I'm going to say this, and it's going to be said correctly, but honestly, a lot of people will mess this up. If you have a minus in the binomial, you are going to alternate your signs on the coefficients. It's going to be plus, minus, plus, minus. The first term, unless this x is negative for some reason, which it's not going to be in this class. So in this class, your first term is this one, and it will be positive. Not the first sign, the first term. So this term is positive, so the 5 gets a negative. Alternating positive, negative, positive, negative. What happens, what people heard sometimes is they say, oh yeah, we go plus, minus, plus, minus, plus, so that their signs are all off. It's the first term that's positive, the 1. Then it's minus, plus, minus, plus, minus. So be very aware that the 1 is positive, and then we're just going to switch signs. So then we're going to, everybody gets an x. and we start with a power of 5, 4, 3, 2, 1, 0. The next thing everybody gets is a 3y. Put the 3y in parentheses, so you don't forget that the 3 is part of this deal. And then power of 5, 4, 3, 2, 1, 0. Plus. Now you clean up the mess, and it's going to take 2 lines for me to do it. And most of my students who try to do it in one screw it up. Doing it in one line does not impress. In fact, it's just the opposite. I look at people who try to do it in one step, and I say they're really lazy, and they must not be very smart. Or they're so lazy, it's overshadowing their smartness. This is going to be x to the 5th minus 5x to the 4th times 3y. We could multiply that and get 15x to the 4th y. But the next one is going to be 10x to the 3rd
9y squared.
in 9y squared. And then 10x squared
27y
to the what? To the 3rd. 27y to the 3rd. Plus 5x, oh God,
81.
thank you, 81 y to the 4th minus 43 y to the 5th. So there's still ones that need to be cleaned up. These 3 terms still need to be cleaned up. It's simplified. Is everybody with me to here? Nick?
Put 2 on the last. Yeah.
5 x to the 1st, 3 to the 4th is 81, y to the 4th. And this is 27y to the 3rd and 9y to the 2nd. And so now what we have to do is we have to multiply those. So we have x to the 5th minus 15x to the 4th y plus 90x to the 3rd y to the 2nd minus 270 x squared y to the 3rd plus 405 x y to the 4th minus 243 y to the 5th. I expect you to be able to raise 3 to the 5th power without a calculator. It's just not that hard. You already have 3 to the 1st here. You have 3 to the 2nd is 9. 9 times 3 is 27. That's 3 to the 3rd. 27 times 3 is 81. That's what 3 to the 4th is. And 81 times 3 is 243. It's not that hard to do. But you have to be able to get down to this level. And it's kind of a pain. It's all about step by step by step by step. It's not pushing the ball through the bars. It's figuring out the puzzle. And you're just doing one thing at a time. Okay? The 4th row of Pascal's triangle. The 4th row of Pascal's triangle. 1, 4,
6,
4. Everybody gets a
2x.
2x, and everybody gets a 3y. See if you can complete it. Everybody's going to get. All right, so 1, 4, 6, 4, 1. Make sure we're going to start with the 2x, 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 and 2x. Over the years, I've had a few people forget to put parentheses around this, so that the only thing that got the power was the x. And it went 4, 3, 2, 1, and 0. These are all pluses. And then the y's, also in parentheses, 0, 1, 2, 3, and 4. And then clean it up. But again, the parentheses are a big deal. The first one becomes 16x to the 4th plus 4 times 8x cubed times 3y plus 6 times 4x squared times 9y squared plus 4 times 2x times 27y to the 3rd plus 81y to the 4th. That should be your third line, or your second one after this. And then multiply the constants together. Are you okay? We were worried about you.
Go to the library.
Uh-huh. Which was it, the bathroom or the library?
It was in the library. It was the bathroom, then I went to the library.
Oh, I see.
I'm sorry.
So then 96, x to the 3rd y. 6 times 4 times 9. Little help?
260.
Thank you. X squared, y squared. And 8 times 27,
260.
again.
Yeah.
XY cubed. And then 81, y to the 4th.
What's like a good number for like the exponent to remember in our head for Pascal's triangle?
Oh gosh, I would never do that.
Well, like, what do you think like the highest one you're gonna get?
I'm probably not going to go more than a 6.
Okay.
I mean, realistically. Now, what I might do is just to say, what the heck is, give me the 10th row of Pascal's triangle. But again, my feeling on Pascal's triangle is, you can knock this out in 30 seconds on a test, on a quiz. So that's why I don't memorize these things. You're welcome to, and if you want to go down to row 6, you'd be in great shape. But I got so much clutter in my head as it is. Why, if I can generate that in 30 seconds, why would I want to spend all that time? So I would just knock this out pretty quick. Everybody good on this example? I guess it was this one. If it's a plus, everybody's plus. If it's a minus, first term is plus, that means the 1. The second term is the minus. Yeah.
On the last row, it should be 72, that's the third line, at the bottom, the last line, 96, should be 72.
Could be. What do we think?
4 times 8 times 3 is 72.
4 times 8 is 32, times 3 I think is 96. Did you do 4 times 6?
Yeah, I did it wrong.
And that, sometimes that's why I want you to not use a calculator. Not that you're more apt to do it wrong on the calculator, but I think that it's just not what we... So this is the second assignment. Take 6 times 4, 19, 20, 24 to 31, and 48 to 51. Don't write too small, and don't cheat yourself on space.
What number are you on?
And we're quizzing on... No, it won't be Monday. I think it'll be Tuesday, though. I saw the quiz, but I can't remember what day it was. I think we're going to quiz Tuesday. Tuesday on the first 3 sections. So we'll do section 3 on Monday, and then maybe it'll be Wednesday. She has it on Thursday, but I think we can talk. Right, 9-1 to 9-3 quiz. It's a collaboration day Wednesday, and we already did part of 9-4. We may be quiz to Wednesday. Won't be Monday or Tuesday, of course. coordinates.